Hello, Summer 307 students. It is my pleasure to welcome you to this video. And in this particular video, I'm going to introduce you to a particular kind of statistical analysis known as a simple regression analysis, simple linear regression analysis. And so essentially what our objective is whenever we conduct a simple linear regression is we want to build a model that allows us to predict the value of y, which is our outcome variable, based on a given value of x, which is our predictor variable. So when we discussed correlations in my previous video, when we talked about scatter plots, right? So with a scatter plot, you have one variable graphed on the x-axis and one variable graphed on the y-axis, and you have data points of individual participants referenced in various dots, right? So if you have a significant correlation, all of the dots will cluster in a linear fashion. So you'll be able to draw kind of an imaginary line that captures the nature of the correlation, whether it's an inverse relationship or a negative relationship or a direct relationship, which is a positive correlation. So essentially, what we are doing with a regression analysis is we're trying to plot the best fitting line. Okay? So regression is a technique that determines which of many possible lines provides the best summary of the relationship between variable x and variable y, right? So like with a correlational analysis, we have one continuous predictor variable denoted by x, okay? And we use that to predict the value of our outcome variable denoted by y, okay? So to calculate this best fitting line and to give ourselves an equation that allows us to estimate y given x, okay, we utilize two calculations in particular. One is denoted with the Greek notation alpha, and that refers to the intercept. And the other calculation, referred to by the Greek letter beta, is known as the slope. Okay? And again, we use this equation to predict the value of y for any given value of x. And to denote that this is our prediction rather than an actual value, we use a notation called y hat. Okay, so most of you remember sometime in middle school when you were first introduced to algebra, learning about the basic equation for a line, right? So the basic equation for a line is y equals mx plus b. Okay, and in this equation, m is equal to the slope of the line, and b is equal to the y-intercept, okay? So we can transform this equation slightly so that we can use it to predict our value of y given a value of x, okay? And again, in this equation, the alpha value represents the intercept of the regression line, which is the predicted value of y if x equals 0. Beta represents the slope of the regression line, which denotes that every time a given value of x increases by 1, we would predict that y will increase by beta. Okay? And because our estimates are not perfect, okay, we also include that E symbol, which represents error. Okay. And this will make more sense in just a moment. Okay. So again, what is the function of regression? Whenever we do a linear regression analysis, what we're trying to do is find the best fitting line that minimizes the amount of what's called squared error. And that's just the distance between each point, each data point, and the line. Okay, so we're trying to again find the line that best approximates or is closest to our scatter plot of data. Okay, so our null hypothesis is that the slope of the line, or beta, equals 0. Okay, so if the slope of our line is not different from 0, okay, then knowing the value of x isn't really going to help us predict the value of y. And fortunately for our purposes, we are going to test this using SPSS. So SPSS is going to tell us whether our predictor variable, or x, is significant or not. Okay? And you guys will learn more about this when you do your SPSS tutorial for correlation and regression this week. Okay? So if beta, or the slope, is equal to 0, then we can't use x to predict a given value of y. Okay? But if x and y are related and beta is not equal to 0, then we can utilize x to help us better predict the value of y. Okay? And I realize this is very abstract, so I think going through an example would be helpful. Okay? So let's say our variables, okay, so our x variable, or our predictor variable, is the cost of a couple's wedding, okay, and the criterion variable, or y, is the years that that couple will stay married. Okay? So essentially we are trying to use the cost of a wedding to predict how many years the couple will be married. Okay? So let's say we run a regression analysis in SPSS and we get this equation. Okay? So our equation is y hat equals 60 minus 0.75. Okay? So basically, what we can do is we can predict what y will be, or we can predict how long a given couple will stay married given the value of x, which is how much money they spend on their wedding. Okay? So again, what do these values represent? Well, alpha represents the y-intercept, which is the predicted value of y if x is equal to 0. Okay? And beta represents the slope of the line. Okay? But all we have to do to use this equation to predict the value of y hat, okay, is sub in that value of x. Okay? So let's look at our plot that we have, or our graph, right? So on the x-axis, we have, like I said, the cost of a couple's wedding. and the units are in thousands of dollars. Okay, so the 10 is actually $10,000. The 40 is actually $40,000, and so on. And then the variable on the y-axis, okay, is the number of years that we predict the couple will stay married. Okay? All right, so our first value of x is 20, okay? 20,000, okay? But because the 20 is already in units of 1,000, okay, what we would do is we would multiply the slope, which is negative 0.75, by 20, and that would give us 15, okay? So our equation would then be 60 minus 15. 60 minus 15 equals 45, okay? So therefore, we would predict that a couple that spends $20,000 on their wedding would stay married for 45 years, okay? And then we would do the same thing for the 70,000. So we would multiply negative 0.75 by 70, and that would give us 52.5. Okay, so 60 minus 52.5. Okay, we would predict that somebody who spends $70,000 on a wedding would stay married for 7.5 years. Okay, and in fact, if you look at the best fitting line, okay, where the line intercepts, okay, if we go to $0, okay, the line intercepts at 60, which is where we get our alpha value or our y-intercept from, right? Because that's the value of y given a value of 0 for x, okay? And then if we go to our first calculation, right, where our given value of x is 20, okay, the line intercepts halfway between 40 and 50, which is equal to 45, okay. And if we go to 70, it's a little harder to visualize, but the line intercepts a little bit below 10, right? So that's where we get our 7.5 from, okay? Or excuse me, our 7.5, okay? All right. So I want to tell you a little bit more about our error term, okay? So again, our predicted value of y, okay, or the value that we predict for our criterion variable given a given value of our predictor, okay, obviously they're not going to be perfect. So when we talked about t-tests, okay, we discussed a concept known as standard error, okay, and this is very similar. Every time we make an estimate using a linear regression analysis, there will be some degree of error associated with our prediction, okay? And we see this with correlations as well. So for example, if we have a perfect correlation or a Pearson R of 1.0, then standard error is equal to 0 because our prediction will be exactly right every single time, right? So another way of saying that, right, is standard error is greater when there is no correlation between x and y. Okay. A lot of times, instead of doing a simple regression analysis with a single predictor variable, we can undergo a multiple regression analysis. And in this case, we look at several continuous predictor variables and use them to predict our one continuous outcome variable. Okay? And in this case, we would utilize the same equation, except instead of having y hat equal to alpha plus beta multiplied by x, we would have multiple beta terms. Okay? And what's good about this is if we have multiple predictor variables, in most situations, that is going to give us a better estimate of y, okay? Because we can explain more variance in y by including multiple predictors, okay? So, for example, if we were looking at the criterion variable of GPAs, right? So if we were trying to estimate students' GPAs, okay, if we knew their SAT score as well as how much TV they watched per week, okay, those variables could give us unique insight into some of the factors that might be influencing their GPA, right? But we want to make sure that all of our beta values or all of our potential predictors provide unique information, right? Because if all of our predictors are correlated to each other, then essentially they're going to be redundant, or they're going to provide redundant information about y. So ideally, we want each predictor to, like I said, contribute unique information that therefore improves our ability to predict y, right? So for example, if we're using SAT scores to predict college grades in college, right? Knowing high school GPA probably won't improve our estimate very much, since SAT score and high school GPA are probably very much related to each other, right? So maybe knowing something else, like knowing number of extracurriculars, or knowing number of other responsibilities, right? Whether the person has a job or things like that, when they're in college versus students that don't, right? That would tell us more, that would give us more information about potential factors that could influence GPA. Okay. So what we would do again in SPSS is we would test each predictor's beta value individually to determine if some are helpful and some aren't. Okay, so I realized this was a really quick lecture video, and I would encourage you to, of course, text me or email me if you have any questions. But I think the most helpful exercise you can engage in for this week is looking through the SPSS tutorial for correlation and regression, because that is where all of your homework problems are going to come from. So as long as you understand how to use the equation for y hat to solve for y hat given a value of x, and you understand how to do a regression and correlational analysis in SPSS, you should be in great shape. But certainly if you have any questions, feel free to contact me. Feel free to schedule an appointment or come during my office hours, and we can absolutely chat about all of this. Okay, so I hope you guys have a great day, and I will see you in my next video.